Good evening. This is me, Mr. Morales. This is the last video for Unit 8. Now, I don't know if you recognize that guy, but that's me, pointing at you. But today, we're going to be simplifying non-perfect monomial square roots. Now, I want you to make a note of something. It is only possible to take the square root of variables with even exponents. So make sure you fill that into your notes. So let's look at number 7 in your packet problem. It says so y to the 5th power. So one way you can look at this is you have 5 y's. And because you have 5 y's, we're looking for sets of 2 y's. So you have 2 sets of y's. And this can be represented out here with y squared, because you have 2 sets of 2 y's. So if this is gone and this is gone, notice I still have 1 y left inside the square root symbol. So my answer here is y squared on the outside with 1 y left still on the inside. And that's okay. Let's try another one. Now we have a squared b to the 3rd. So again, you can make this as a times b times b times b. So I have one set of a's that can be represented out here by a. So that's gone. I have one set of b's that can be represented out here with a b. And that's gone. But I don't have another set of b's. So I still have a remainder of b in my problem. So my answer here is a times b, that's what I have out here, the square root times the square root of the remainder b that is still left inside my square root symbol. That's number 8 in your packet. Let's look at number 9 in our packet. I have x squared, so again I can rewrite this with 2 x's. I have 3 y's. And I have 4 z's. And I can put it this way if you want. So let's take a look. I have one set of x's, so I can represent that out of here with an x. I have one set of y's that can be represented out here with a y. So that's gone and that's gone. I don't have another set of y's to make, so that stays there. And I have 2 sets of z's. And all those can be represented here with a z squared, because I have 2 sets of 2 z's. So that's gone and that's gone. So my final answer here would be xyz squared and times the square root of this y right here that is left over. X times y times z squared times the square root of y. That's number 9. Let's look at number 13. So we have 2 more left. Now we have a number in here. We have a square root of 100 times x to the 5th y squared. So hopefully by now you know that the square root of 100 is 10 times 10, and the square root of 100 is 10. So there's the one set. That can be gone. Now let's look at the x's. And if you want to, you can do it like this. X to the 2nd, x to the 2nd, and 1x. Because this is 2 plus 2 is 1. So I have 2 sets of x squares. So that's x squared. Now if you don't want to write it like this, that's okay. Just write it out. I have 5 x's, and there's one group, there's 2 groups, and again, that's shown right here, and I still have 1 x left. Now we have y squared, so I have 2 y's, so I have a set of y's, and that can be represented out here. So my final answer is 10x squared y times the square root of this 1x that we did not use, which goes in there. So the square root of 100 is 10. We have 5 x's. We found 2 groups of 2's. And then we have 1 group of y's. And this 1x was not used, so it goes there. This one's number 18 in your package. I think you have to flip the page. So I believe the square root of 108 is 36 times 3. So here, I have 36 times 3. And the square root of 36 is 6, so that goes here. So that's gone. I have 2 r's. I have 3 s's. And oh my God, I have 6 t's. But I can do 1, 2, 3, 4, 5, 6. So let's see what we got. I have 1 group of r's. That goes here. That's gone. I have 1 group of s's. Also goes out here. And that's gone. I have 1, 2, 3 groups of t's, which can be represented out here with a t to the 3rd power. So my final answer is 6 r s t to the 3rd times the square root. Do we have anything left? We have a 3 left, right there, and an s left, right there. So times 3s. So that is our final answer. Hopefully this video has been helpful. Please try to pursue to do some of the other problems in the worksheets and be ready to go over them in class. Have a great night.